Now we want to talk about worksheet 3A. This is a worksheet that was actually given out to the in-person or face-to-face classes. So I want to go over these with you since we don't have a class that I could help you work through the problems. Here it says work in your group, which obviously you don't have a group, so ignore that. You do not have to turn these in, and the worksheet will not be graded. Below, find 12 descriptions labeled A through L and determine what belongs together and make 4 groups, 3 choices each. No choices should be repeated. Here's the part that you need to know. How we're dividing them into groups is we're using the quadrants. We want to look at each one of these and decide what quadrant we're in, okay? 40 degrees is going to be more than 0 and less than 90. I'm going to use the circle that they have drawn in C, and then I'll erase it. When we're talking about degrees, and then this 0 is the same as 360 degrees. So now if I want to know where 40 degrees is, well, I know it's somewhere between 0 and 90. So it's in quadrant 1. B. Remember, cosine is the x value. Cosine of theta is the x value, and the sine of theta is the same as the y value. If I have cosine is positive, so I know cosine is positive to the right of the y-axis, and sine is negative below the x-axis. So that would give me quadrant 4. In quadrant 4, x is positive and y is negative. So the answer to B is Q4. The answer to C, they've given us a picture, and you can see that that line is in quadrant 3. 330 degrees, well, it's between 270 and 360, so that is quadrant 4. Cosine is negative is to the left of the y-axis, and sine is positive above the x-axis. So that would leave me in quadrant 2. Here, x is negative, y is positive. This is in quadrant 2. Okay. We have F. F is, again, obviously in quadrant 2. Hopefully you know your quadrants. 230 degrees. Again, I look at my circle on C, and I can see that 230 degrees is between 180 and 270, which makes that in quadrant 3. Okay, cosine is positive. Cosine is positive. X is positive to the right of the y-axis. Sine is positive. That everything positive is in quadrant 1. I is just a drawing, and hopefully everybody knows that's quadrant 4. And 135 degrees. Again, I'm going to look up at C. It's between 90 and 180, which means it is in quadrant 2. Here, I'm going to write this down on my paper. So K, cosine is negative. I'm going to color in this circle in I. So cosine is negative everywhere here, because that's where x is negative. And then sine is negative just everywhere here, right? Underneath the x-axis. So where they intersect is in quadrant 3. Cosine is negative, or x is negative, and y is negative in quadrant 3. L is just a picture. Hopefully, you know that's quadrant 1. Okay, so now we're going to group them together. So group 1 is quadrant 1. That was A, H, and L. Group 2, quadrant 2, is E, F, J, E, F, J. Group 3 is C, G, C, G, and K. K is right there. And group 4 is D, I, D, I, and B, I'm sorry, and B. So number 2, the unit circle is a circle in the Cartesian plane centered at 0, 0 with radius equal 1. And the equation is always x squared plus y squared equals 1. And you can think of this still as that is the equation of a circle. And if we make a triangle inside of that circle, it's also the equation of every right triangle that I can put into that unit circle. It's 1 because the radius of a unit circle is 1. So given the following, that these are 30, 60, 90 triangles, label the missing sides for the 30, 60, 90 triangle with a hypotenuse of 1. These are exactly the same triangle. These are called similar triangles. They're not equal, obviously, because 2 is not equal to 1. I can turn this first triangle into a triangle inside the unit circle by dividing everything by 2. Right? I'm just proportionately dividing everything by 2, which means that x is going to be equal to the square root of 3 over 2. Y is going to be equal to 1/2, because multiply by 1/2. I'm given a 45, 45, 90. One really important thing about a 45, 45, 90 is that remember that 2 sides are always going to be the same, because the angle across from the side dictates how big that side is. Since both of the angles are 45, both of the sides have to be the same. Obviously, I have to divide everything by the square root of 2. I want to divide this side by the square root of 2. Now I have 1 as my hypotenuse. I have to rationalize this 1 over the square root of 2. The way I rationalize it is I multiply by the square root of 2 over the square root of 2, which gives me the square root of 2 over 2, which, if you've watched the unit circle video, you'll notice is exactly what the x and y values are at 45 degrees. So, and the same thing is true for the y. They are equivalent at that point. Okay. Suppose the circle below is a unit circle. Draw a 30-degree reference angle in each quadrant. Well, there's my 30 degrees in quadrant 1. So if I want to draw a 30-degree reference angle in quadrant 2, because remember that the reference angle always attaches itself to the x-axis, never the y-axis. Don't ever use the y-axis. It would give me a completely different triangle. You can see that whatever the value is here, this x and this y, well, that's the length of this x and the length of that y. So if I take that same exact triangle and I flip it over the y-axis, my values stay the same, right? I didn't change anything. So this is going to be negative x and positive y. Now, and this is 30 degrees. And that's my reference angle. I can also flip it into, I can take that same triangle, I'm gonna flip it down into the third quadrant. And now there's my 30-degree reference angle. And again, this is now negative x, negative y. And then again, I go down like that, and then here, and this is 30 degrees, and that's my reference angle in the fourth quadrant. And in the fourth quadrant, this is positive x and negative y. So once I know x, y, and I know my reference angle, I know every point on the unit circle. Label the angles. I did. Draw a point where each triangle intersects the unit circle and label the order. Okay, I did it already. So I actually completed this entire thing. At 30 degrees, we can see that the x-axis is larger than the y-axis. So my x value has to be larger than my y value. These are the only values you actually need to memorize, are the ones around that hit the axis, and 30, 60, 45. So this is 45. This is at 30 degrees. And if it was at 60 degrees, the only thing that would change is now you can see that the y value is bigger than my x value. So I flip these numbers. And then depending on what quadrant I'm in, depends on what the sign is in that quadrant. Here I have, okay, I guess we're gonna do for each one. So here's my 60, 30, not 90. And again, this is 1/2, comma, square root of 3/2. I just explained why. And then in each quadrant, these are the reference angles. That's 60 degrees. This is 60 degrees also. That is 60 degrees also. And again, as I move around, I would have, depending on what quadrant, I'd have either X or Y or both positive or negative. And I think that's pretty much it. I'm gonna let you fill out the rest. I think you can fill out the rest. 45 degrees is halfway between 0 and 90. So here is my triangle. This is 45 degrees. And again, if I want to put it in every quadrant, so it flips over here, this is 45 degrees. Hopefully you're seeing the pattern in all of this. This is 45 degrees, and this is 45 degrees. And as you can see, the reference angle, I'm always connecting it to the x-axis, never connecting it to the y-axis. Find the reference angles. So let's do these. Reference angles are really important. I have no issue doing more of them. Find the reference angles. Recall that an angle's reference angle is the acute angle formed by the terminal side of the angle and the horizontal axis. Reference angles are always between 0 and 90 degrees. Or just remember, they're always in quadrant 1. Because in radians, they're going to stay in radians. 100 degrees, well, this is 90. This is 180. So 100 is in quadrant 2, somewhere around here. If I want to find my reference angle, it is this angle that's connecting that terminal angle to the x-axis. Okay, so if I know that this is 100, then I know that the rest of it must be 80. From here to here has to be 80 degrees because the total of those two have to equal 180. So this is 80 degrees. 530, well, 530 is not between 0 and 360. So what do I have to do? I have to subtract 360 from it, just like I was subtracting 2 pi. So for B, I would say it's 530. I find the coterminal angle by subtracting 360, and that gives me 170 degrees. And now we know 170 degrees. It's this. Again, we know 170 degrees is in quadrant 2, somewhere close to 180. And I'm looking for this value here. I know this is 170. So that little piece extra must be 10. Negative 125 degrees. Well, this is negative 90. So negative 125 must be in quadrant 3 because I have to go more than 90. This is not the reference angle. Do not make that the reference angle. Remember, the reference angle always connects to the x-axis. If this right here is negative 125, then that little piece more, 125 plus that little piece has to equal 180. So 180 minus 125 is 55. So this is 55 degrees. And notice every single one of these numbers that I call my reference angles are between 0 and 90 and positive. It's always between 0 and 90 and positive. Think about it like this. We're referencing back to quadrant 1. Now we have 5 pi over 6. Again, whenever we think of radians, we have to think about, so we have to think about this as 0, pi over 2. 3 pi over 2 is 1.5 pi. And if I continue all the way through, this is 2 pi, same as 0. So 5 pi over 6. Well, 5/6 is definitely less than 1. And then 5/6, is it more than 1/2 or less than 1/2? Well, 3/6 is 1/2, so 5/6 must be more than 1/2. Since it's more than 1/2, it's got to be in quadrant 2. If this is 5 pi over 6, and what I want is this, that's the reference angle. The reference angle is in red. I want this piece, this little red piece. So I'll call this the reference angle. 5 pi over 6. That's got to equal pi. Theta sub r, or my reference angle, is pi minus 5 pi over 6, which is 6 pi over 6 minus 5 pi over 6, which gives me pi over 6. 7 pi over 4, first thing I want to do, since it's more than 1, I really want to turn it into a mixed number. So 7 divided by 4 is 1 3/4 pi. So it's more than 1 and it's less than 2. So now we're talking about it being in one of the bottom 2 quadrants. That's the 1. And then 3/4 is more than 1/2. 3/4, so I go 1, and then I go 3/4 more. 3/4 is more than 1/2. So that lands me in quadrant 4. This is my reference angle. And this is a little different because I want to say that this plus my reference angle is equal to 2 pi, not 0. So I say that if I add those two together, I get to 2 pi. So theta sub r is equal to And we can turn it back now to 7 pi over 4. So if I need a 4 in the denominator here, this would be 8 pi over 4 minus 7 pi over 4, which is pi over 4. In quadrant 4, 7 pi over 4 is in quadrant 4, and the reference angle is pi over 4. Now this last one, this is something that actually requires more explanation than I can give you at the moment. So a laser rangefinder records the distance from the laser to the base and from the laser to the top of the building shown in this figure. And I want to find theta, a triangle. I'm going to take the building out because the building is just kind of in the way. I know this is 60 meters. I know this is 100 meters. And I know this is h. Now, this would come from the right triangle video. If you haven't watched the right triangle video, this probably won't make sense, I don't think, because this is now outside of the unit circle, right? Because the only way we could talk about this being in the unit circle is if the hypotenuse was 1. And some of you already know this, and some of you have memorized this, so I'm just gonna write it down. This is something that people really like. So, ka, toa. And what that means is that the sine is equal to the opposite over the hypotenuse, the cosine is equal to the adjacent over the hypotenuse, and the tangent is equal to the opposite over the adjacent. So if I call this my angle, then my opposite is here. My adjacent is here, adjacent to that angle. And this, you would call this the hypotenuse, which I think you would know. Okay, so now I have my adjacent, my opposite, and my hypotenuse. So we want to find the angle and the height. Well, how do I find the angle? I have the adjacent and I have the hypotenuse. I have the adjacent is 60. And the adjacent and the hypotenuse means that the cosine of theta is equal to the adjacent over the hypotenuse. And let's simplify this. You don't have to simplify this. This is going to be a calculator problem anyway. I just like to simplify things. So I cancel the zeros. And this would divide both by 2. I get 3/5, right? Well, if I get 3/5 there, I could probably easily figure out now, I don't have, when I'm using my Pythagorean theorem, if I use my Pythagorean theorem, I'm not going to use the Pythagorean theorem for this. You can use the Pythagorean theorem to find the height, okay? And I think you all know how to do that. So I'm going to leave that up to you. And you can check my work because I'm just going to use trigonometry. Now, here's the part that I haven't taught you yet. I can attach a video, but the video is much more complicated than you need at the moment. What I think I'll attach is a video on inverse functions that are not trig functions, because in that video, I explain a lot more about inverse functions. And I think that that might be a good thing for you to understand. But inverse functions basically cancel functions. So for example, if I have the square root of x equals 4, and I want to solve for x, I will square both sides. I square both sides because the square root is a function, and the only way I can get rid of a function is to take its inverse. I cannot divide by cosine any more than if I had this and you wanted me to solve it, instead of taking the square root of both sides, well, actually, let me finish this. So if I have something like this, then the square root and the square cancel because those are inverses of each other. And I just get x equals 16. Okay. I'm going to take the inverse of both sides. The inverse and the cosine cancel just like the square root and the square cancel. And I get theta is equal to the inverse cosine of 3/5. And it doesn't say here, but I don't think it says find the angle. We're going to do the angle in degrees, even though it doesn't say. If we have something like this where we're measuring angles and from the ground to the building, we wouldn't probably use radians for that anyway. There's on my calculator, there's a button that says DRG. That means degrees, radians, or gradients. I have to make sure that I press on that until I get to degrees. Okay. And then on my calculator, I don't know, again, if you're having trouble with your calculator, let me know. But on my calculator, I have to hit like the shift, which is the same as the second on most calculators. And above the cosine, it says cosine to the -1, which is inverse. Inverse cosine. And I get theta equals 53.13 degrees. So I've now found theta. Again, there's two ways to find the height. One way to find the height is to use Pythagorean theorem. You could say 60 squared plus h squared is equal to 100 squared. And you can solve it that way. But since we're working on trigonometry, let's solve it a different way, because h is opposite. So and I already know my hypotenuse, so I can say the sine, and now I know the angle. Once I know the angle, it's very easy. I can put it in the calculator. The sine of 53.13 degrees is equal to the opposite, which is h, over the hypotenuse, which is 100. H is equal to 100 times the sine of 53.13. And now this is a very straightforward calculator problem. I get 0.7999998, which is pretty close to 0.8 times 100 equals. I'm just going to round this off to the height being 80. I've now found the height using trigonometry. I guess we can do it here using Pythagorean identity and see how they connect. So I would have 100 squared minus 60 squared, which is equal to 6. So h squared is equal to 6,400. Which means h is equal to 80. So either way, and it's 80 meters. Both of these are meters. Either way, I get the same answer. That's how you solve for theta when you have a value. So that's the end of worksheet 3A and the end of this video. Thank you.